Okay, so this basically tells you about a little bit about the properties of multigrid. Basically, by going to the coarse grid, even with the same number of iterations, you get a faster convergence, right? So just to make it a little bit more convincing, let's actually pardon? Okay, so let's actually write a proper code to do this. So let's x equal to 0, 65, and let's make 200 iterations versus 10 Jacobi versus 10 multigrid cycles. BC and x Jacobi equal to x. All right. Okay, so then we initialize this again, and let's do 10 iterations, multigrid, x and BC. Is that yes? Does it make? Oh, sorry. Yeah, that's a wrong thing. So for I equal to 1 to 200. Yeah, thanks. And do Jacobi and all right. Okay, so this is thanks for pointing out the bug. Okay, so now let me do this again. Two subplots and compare. Right. So basically, what you see is that yeah, you get a little bit more out of the multigrid. I'm a bit worried about, is there a bug on this? Let's see the interpolation. Right. Okay. Because this is looks like you have a white and black on this one. Do you see any problem onto this implementation here? Yeah, so let's actually do that. For I goes from 1 to 100, x equal to multigrid xbc. So let's show this. Oh, still like that. So I think there might be a problem involved in this. Let's. Oh, okay. So yeah, I showed the wrong thing, right? So, oh, okay. So now I'm showing the actual x. So looks like that's doing the right thing. Okay. So this is the x, and let me also show the converged one. The true solution. The true solution is this. This is after how many? 100 multigrid. This is after 10 multigrid. This is after 200 Jacobi iterations. All right. Okay.
So the 10 multigrids so also involve 10 Jacobi each. Right?
The 10 multigrid involves 10 Jacobi on fine grid each and 10 Jacobi on the coarse grid each.
Right. So 100 multigrids also involve 100.
It involves about 200 Jacobi iterations.
10 times plus.
Oh, you are saying 10? Sorry. 100 multigrid iterations involves 2,000 Jacobi iterations, actually.
Yeah, but like 1,000 on the fine grid and 1,000 on the coarse.
Yes.
So the course is not as expensive, right? But like
right.
We want to compare operations.
Right. Yeah. So yeah, you can. So let's actually do a comparison between. So this picture is now 100 multigrid cycle, right? So x equal to 0. So let's compare. You want to compare with 1,000 Jacobi iterations. And let's actually put it in the first one. Let's show this. Right, so this is 1,000 iterations of Jacobi versus this is 100 iterations of multigrid. And this is the true solution, right? So you can still see the darkness in the middle of the domain while the multigrid looks pretty good. So another thing I want to show you is that here, when solving this cross-grid solution, right, we don't have to actually use just the Jacobi iteration. We can use multigrid again. We can essentially say that EC is equal to multigrid of EC RC, right? So we can just get rid of this part. Except for now this is a recursive call, and the recursive call has to have an endpoint. So when the grid is close enough, we shouldn't do this at all. So basically, this is only if size of B1 is greater than what? 3, right? Okay. Well, let's just say if the size is greater than 1. So basically, if B has a size of 3, the Jacobi iteration should be converging in 1 step. We're doing 10 steps. It doesn't really matter, right? Okay.